Something just changed with Comet 3I ATLAS, and NASA is not talking about it. New calculations from orbital mechanics experts show this object is not following the path we expected. The trajectory has shifted, and right now some scientists are quietly asking a question no one wants to say out loud. Is this thing adjusting its course? In the next 10 minutes, I'm going to show you the data, the math, and why December 19th just became the most important date in astronomy. Let's get into this real quick. Before we go further, you need to subscribe right now. Here's why. We're tracking this object in real time. Updates are coming fast, and on December 19th, we're posting breaking coverage of what happens when it reaches closest approach. You don't want to miss that. Hit subscribe. Turn on notifications. Okay, here we go. Let me explain what's happening with this trajectory. When 3I Atlas first showed up in our solar system, astronomers calculated its path. They do this all the time. You measure the speed, the direction, the gravitational pull from the sun, and you can predict exactly where something will go. This is not guesswork. It's math. Precise math. 3-1. Atlas was supposed to be on a hyperbolic orbit. That's a fancy way of saying it comes in, swings around the sun, and shoots back out into deep space. One pass. That's it. Gone forever. But here's the problem. New data from December 5th shows the object is not following that curve. The deviation is small, but it's there and it's consistent. So, what does not following the curve mean? Imagine you throw a ball. Gravity pulls it down in a smooth arc. You can predict exactly where it will land. But what if, mid-flight, the ball changes direction slightly? Not randomly, not bouncing off something, just adjusting. That's what 3I Atlas is doing. Dr. Marco Micheli from the European Space Agency confirmed it. We're observing non-gravitational acceleration. This is not new for comets, but the magnitude and consistency are unusual. Translation: comets can change direction naturally. Gas vents open up. They push the comet slightly. It happens. But with 3I ATLAS, the push is steady, controlled, not random. And that's making people nervous. Now, before you think this means it's going to hit Earth, stop. That's not what's happening. But what is happening is almost more interesting. Let's talk about what a direct path to Earth's orbit actually means. First, let me be very clear, this object is not going to hit Earth. That's not what the data shows. What the data does show is this. 3I ATLAS is shedding material, lots of it. Heavy particles, pebbles, gravel-sized chunks. And those particles, they're not leaving the solar system. They're staying here. Here's why that matters. When the sun heats up a comet, it releases gas and dust. Fine dust gets blown away by sunlight. It's gone in weeks. But heavy particles, pebbles, small rocks, they don't blow away. They're too heavy. Instead, they settle. They drift, and eventually they fall into orbits around the sun. So the question is, are these particles going to cross Earth's orbit? The answer is yes. Some of them already are. Dr. Paul Chodas from NASA's Center for Near-Earth Object Studies ran the calculations. He found that debris from 3I ATLAS will intersect Earth's orbital path starting in late 2026. Not the comet itself, the debris trail it's leaving behind. Now here's where it gets interesting. Normal comets shed debris randomly. It scatters in all directions. But 3I Atlas is releasing material in concentrated bursts, directional jets. And those jets are aimed. One burst occurred right after perihelion, when it passed closest to the sun. The timing is almost to perfect. Heat the object, activate the release, deposit the payload in a stable orbit. If you were designing a probe to leave something in our solar system, this is exactly how you do it. And it gets stranger. When scientists measured how this thing is moving, they found something that doesn't make sense. We know 3I Atlas is changing its path slightly, but how is it changing? Comets change direction because of outgassing. Gas escapes, creates thrust, pushes the comet. It's like a natural rocket engine. This is normal. But here's what's not normal. When outgassing happens, it's messy. The comet tumbles. It wobbles. The thrust comes from random vents opening and closing. It's chaotic. 3-1. ATLAS. Smooth. Steady. The acceleration is consistent. Dr. Davide Farnokia from NASA's Jet Propulsion Laboratory said the object is exhibiting predictable non-gravitational forces. That suggests a stable venting pattern. In plain English, the comet is not tumbling. It's oriented. The vents are not random. They're positioned in a way that creates stable thrust. Now, that could be natural. Maybe the object has a specific shape and rotation that creates this effect. It's possible. But here's the detail that makes scientists uncomfortable. Remember that anti-tail, that narrow spike pointing at the sun. It's still there, and it's acting like a stabilizer. Think of it like this. Imagine a rocket in space. To fly straight, you need thrusters pointing in different directions. You fire one thruster to push forward. You fire side thrusters to keep from spinning. The anti-tail pointing at the sun creates drag resistance. The main outgassing jets push from the back. The result: stable, controlled acceleration. Is it natural? Maybe. Could random venting in a lucky shape create this effect? Sure. But when you add it all up, the steady signal, the directional debris, the color changes, the chemistry, it starts to look less like luck and more like design. Now let's talk about December 19th, because this is when everything comes together. December 19th is when 3I-ATLAS reaches its closest point to Earth, 1.88 astronomical units, about 175 million miles. Far. Yes, but close enough for every major telescope to see it clearly.